From AccuWeather.com, this is AccuWeather Daily, a brief host-read article. It's weather news in a nutshell. Let's take a step away from winter storm stories and coverage here on the podcast to talk about something completely different. Space junk. So, the threat of space junk falling out of orbit and crashing toward Earth is growing. Satellites pass their prime, and old space parts re-enter our planet's atmosphere more than 3 times every day. Now, of course, these objects mostly burn through the atmosphere, but when doing so, they can release harmful substances. And if they reach Earth's surface, well, they can contaminate the environment, as well as possibly collide with things here on the ground, like people. But tracking falling space junk in an effort to mitigate its impact is complicated because this stuff can deorbit quickly as it travels at speeds up to 18,000 miles per hour. Current methods to monitor falling space junk use radar and optical tracking, but these methods struggle to accurately predict where most objects could land, especially if the debris breaks up during reentry into Earth's atmosphere. Now, this lack of precise location data can delay or even prevent the recovery of dangerous toxic space residue. So now researchers from the Johns Hopkins University and Imperial College London say they have found a new way to help spot space junk during reentry. Their approach uses seismometers, the instruments that normally detect earthquakes here on the ground. The trick is to look for data indicating a sonic boom, the shock wave produced when an object exceeds the speed of sound, which the falling debris generates as it tumbles through the atmosphere. The InSight lander, which touched down on Mars's surface back in 2018, has detected more than 1,300 Marsquakes, a handful of which were produced by meteoroids striking the surface rather than by the movement of rocks within the planet. InSight was able to quote-unquote hear these shock waves that the meteoroids produced as they entered the thin atmosphere of Mars and then pinpoint the location of the impact. NASA's Mars Reconnaissance Orbiter was subsequently flown over these craters to study and then photograph them, revealing important insights about the planet's surface. One researcher said, "The big leap was taking some of the techniques we developed for studying natural meteoroids on Earth and Mars and then applying them to the study of space debris on Earth. But in many ways, space debris is quite different to natural space objects. It tends to enter the atmosphere more slowly and at a much shallower angle. It also tends to break up in a much more complicated fashion as well, and indeed pose a much bigger risk to people on the ground." To test the method, the researchers used the uncontrolled re-entry of a Chinese spacecraft that deorbited in 2024 over California. As the spacecraft burned up through the atmosphere, the sonic booms it produced reached the ground, creating vibrations that seismometers picked up, but that did not look like earthquakes. The study looked at data from 125 such instruments, using the intensity of the readings to reconstruct the object's path in the sky. Compared with the projection by the U.S. Space Force using radar data, the sonic booms method returned a trajectory that was 25 miles farther south. The researchers now need more tests to verify the method's viability, saying their end goal is to produce a tool that can integrate into a civil monitoring pipeline. So let's suppose you're worried that something has fallen out of the sky. Well, you'd have a tool based on open source data, which can help you locate where that's happened and potentially inform recovery efforts. The sonic booms would be detected automatically, and researchers say that allows people to track falling debris within seconds or minutes from the start of reentry and then gather important data about the location of potential atmospheric contamination. Estimating an impact site would take slightly longer because other variables, such as the wind, would need to be considered, but the tool would still be able to suggest a location quickly enough to support a rapid response. Scientists point to the 1978 reentry of the Soviet satellite Cosmos 954, which dispersed radioactive debris over northern Canada. And most of that has never been recovered, and it is still radioactive. There are some challenges distinguishing reentry signals caused by space debris from those that come from other sources, such as aircraft, explosions, or natural phenomena. But with careful validation and integration alongside radar, optical, and satellite tracking, the method could become a useful complementary tool rather than a universal fix. That's all for now. You can find regional forecasts and science-based articles at AccuWeather.com, and for your local forecast at your fingertips, download the AccuWeather app. That's all for now. You can find continuing coverage of the winter storm sweeping across the country at AccuWeather.com, and for your local forecast at your fingertips, download the AccuWeather app. Enjoy the rest of your day. Be safe. I'll be back tomorrow with more from AccuWeather.